do is we'll go over our Rosenberg EC module control box here. What we've got inside this box is our Rosenberg EC GKHM 280. It's 280 millimeter, single phase, 200 to 277, 50-60 hertz fan. The module actually includes the stand, the inlet cone, and this pressure sensing tubing. On the front of the module, we've got our pressure sensor. This will actually read pressure from this inlet pressure ring that we've got here. Also in our inlet area here, there's another sensor down here that will tell us the difference. Next to that is our enable potentiometer switch. This will be able to function by controlling the fan on and off. It has failure indicator lights on here, as well as a potentiometer to control the speed and set our set point. Now what we'll do is we'll slowly start to go over the controls and begin to wire up all our controls together here. What we'll do is we'll start from the left and work our way to the right and describe each one of these little terminals. We've got two ground lugs here, and we've got our input voltage here, L1, L2, and L3. This being a single-phase fan, we're only using L1 and L2. For three-phase, you'd use L3. For single-phase EC fans, you do not need a start capacitor, so that's why you won't see one in line here. The next to that, you'll find your alarm sensors. You got a normally open, a common, and a normally closed sensor here. We'll move over again. We'll find our first analog 1. This will be your potentiometer switch, the first speed control that you'll have. You'll have your ground, your 0 to 10 input signal, DC voltage, and you'll have your 10 volt control. Then you'll go over to next, you'll have your analog 2. Your analog 2, you can use a pressure sensor, a temperature sensor, a humidity sensor, any kind of sensor that provides a 0 to 10 input signal that you need to have a secondary monitor. This will go on your analog 2. Again, you've got a ground, a 0 to 10 input signal, and a 24 volt control. Then you move over next, you'll have your enable switch. You've got your 24 volt and your enable. Then you'll slide over one and you'll have your output voltages. You've got an output and a ground. In this case, what you would only use these for is if you were going to tie two fans in line. If you're going to use fan 1 as a master and fan 2 as a slave, you take off here on your output and ground. Then your last four are your RS connectors for hooking up your RS-485 to USB port to operate and monitor this particular fan on your laptop or computer. What we'll do now is that this fan doesn't have any wiring controls on it. We're going to take both of our little jumper wires and we're going to stick these on our controls here on our PW, our 0 to 10 analog 1 PWM, and our control voltage here of plus 10 volts. And we're also going to come over here to our 24 volt and enable switch. And what this will do, this will actually just make the fan run full speed just to make sure that everything works. Before we go too much further, we want to make sure that everything functions properly. We want to make sure everything goes through its series and make sure that it functions. Once power's been applied, you'll hear a click. It's going through a checklist, and the fan will slowly start to come up to speed. Now we just ran the fan for a few minutes just to give you an idea of how it starts up. Every one of our fans will have a soft start feature. Starts slow, builds its way up to speed. Again, we had all our controls jumped out, so this fan was going to run 100% no matter what. No speed control. Now what we'll do is we'll slowly start to begin to wire in our potentiometer. Again, if you don't use one of our Rosenberg potentiometers, your color coding and wiring will be different. So you'll have to make sure to go off the wiring diagram provided for you with the motor. What we'll have is a whole bunch of wires here, and what we'll do first is we'll wire up the alarm sensor. So what we're going to do is we're going to take our red and our white wires, and we'll go across here. One will go to your normally closed, the other will go to your normally open. Now what you'll do is you're going to take one of your jumper wires that we had earlier, and you're going to come off your common line and go over to one of the 24 volt plus controls. Doesn't matter either one, just as long as you're feeding it 24 volts. I normally take it off the enable switch. And then what you'll do is now you'll wire up your enable switch for this fan. In this case, our gray and our pink wires will be our enable switch for our potentiometer control. Again, gray will go to your 24 volt control. Pink goes next over to the enable section. You've got a red and blue wire here. This is your ground wire, and you can come over here to your output section. There's just a ground that goes there, and you're left with brown, blue, and black. Now these wires will go to your actual potentiometer. This will go on your analog 1. So you've got blue will go to your ground, black is your control, your 0 to 10 input control, and brown will be your control voltage of plus 10. Now, all the wires are in place. Jumper wire to give our control voltage to our lights and failure alarms. And the potentiometer is now completely fully wired in. Now when we turn power on, you'll hear a click, and the fan will only go as high as the input voltage provided by the potentiometer. In this case, we have the potentiometer running about half speed. So as soon as we provide power to it, it'll only run about 50%. Again, you'll hear the click. Fan will slowly start to come up to speed. Now right now the fan's running again at like 50% speed. And what we'll do is we'll focus here on our potentiometer. Again, you've got your lights here. If it was a little dark, you could tell that the green light would be on. We got our enable switch, so we can turn the fan on and off. And with this potentiometer control, we can turn the fan all the way off and run it really slow, or ramp it all the way up to 100% if we wish. These fans do run a 1 to 9.5 voltage range. Anything under 1 volt input signal will actually stop the fan. Anything over 9.5 volts input signal will actually run at 100%. Okay, now that we've got our potentiometer in, we've tested it, everything works right, now we're going to wire in our pressure sensor. Again, this goes on your analog 2. It could be a temperature sensor or a humidity sensor. As long as it can read a 0 to 10 input signal, you'll be fine. Again, we've got a blue, a black, and a brown, very similar to how we've got over here on analog 1. And they do wire up the same way. Blue ground, black is your 0 to 10, and brown as your 24 volt control. Now again, potentiometer on analog 1, pressure sensor on analog 2. Now he'll back up a little bit here and we'll concentrate on our controls here. Again, we've got our potentiometer enable switch and we've got our pressure sensor. Pressure sensor got 2 inlet tubes here, one to the inlet cone area. The inlet cone was the blue pressure sensor line that came off the inside back here. He'll pan around. This little blue line here is going to read pressure off that inlet cone, and the other goes to our inlet area. Behind this damper there's another pressure sensor back here, and this will read the difference between the inlet cone area and the inlet area itself. So again, we'll power this thing back up. We got our click. It's going to run through its internal checks, and it'll slowly start to pan up to speed. Again, we've got this thing running at about 50%. We don't want to run it any faster. So the customer, what you would do is, in this case, you can set your damper controls here. The fan again is going to run to 50%. It's going to run at a set RPM, regardless of whether we open this damper full or close it all the way. The fan's not going to change the speed. So now once we get done, we're going to shut this deck down, and then what we're going to do is we're going to wire in our RS-485 to USB connector, hook it up to our laptop, and we'll go over how to run this thing and close